I hope you will be fine. So after midterm, we are going to discuss the Bayes rule. Bayes rule or Bayes theorem is a very fundamental theorem of generative probability theorem. Basically, generative theorems are the theorems or probability models which generate some other probabilities from the given set of probabilities or theorems. So what happens here? Let us have a joint probability of two events, and we have a marginal probability as well. So we can find out the posterior probability of any event by finding the ratio of these two probabilities. Okay, we have discussed it in conditional probability, and we can find it out by using this formula. But in Bayes theorem, we can replace this thing with this one. Okay, how it can be replaced? We know that the probability of A intersection, we can also be written like this one. Okay, these two are basically the equivalent. We can write it like this one, and similarly the marginal probability can also be written like this one. How it can be written like this? We will have an example, and after that example we will discuss all these things, and these things will be here as we have seen. So let us discuss this theorem. Let B1, B2, Bn up to Bn be a partition of a sample space as. Suppose that event A occurs. What is the probability of event Bj? By the definition of the conditional probability, we have this formula, and this by Bayes theorem it can be replaced by this one, where we use the theorem and the total probability to replace PA equation is called Bayes rule. Okay, this is replaced by a total probability theorem. So how can we do it, and what are the basic principles that we have converted this one into this thing? This is discussed here. So let us have an example. Suppose we have a test, and from that test we have got a positive of any cancer. Let us find the probability that we have a test of breast cancer. Let's say breast cancer. Okay, sorry again. We have a test, and that is the test of breast cancer. Let me change it. Okay, that is we want to find out the probability of breast cancer such that we have, what is the probability that we have a male such that we have found a positive breast cancer. How it can be written as? It can be written as the probability that we have a male, and what are the chances that he will have a breast cancer. It will be this one multiplied by the probability of a male. Okay, in the location where we have been testing the people, divided by the probability of breast cancer in a specific area. Okay, we have this formula. So how can we find these things? Okay, first of all, discuss what is the scenario. We have a test, a certain test of breast cancer, and from that test we have to find that what is the probability that the breast cancer is occurred in a male. Okay, what is the probability that a breast cancer has been occurred in a male? Breast cancer is positive, and what is the probability that a patient is a male? It can be written by Bayes theorem just like that. What is the probability of a male probability that a person is male and he has a breast cancer and multiplied by the probability of male. This is the chain rule we have discussed it previously, and divided by the probability of a breast cancer. Okay, this probability of breast cancer can also be written like from this formula. This can also be written like probability of breast cancer is equal to so we know that this breast cancer can occur in both male and female as well, if we don't count the proportion of the other genders as well. We know the other gender as well, but we are not counting that gender because the proportion of that gender is very small. So that's why we will consider that what is the probability of a breast cancer such that we have a male and the probability of male. I am having an issue, so please bear it. And this is the probability of a breast cancer in a male, and multiplied by the proportion of the male in a certain area, plus, as we know that this is the probability of a breast cancer, so breast cancer can also occur in other genders as well, and that gender can be a female. Let's consider only a female. So what is the probability of breast cancer in female multiplied by the probability of a female in certain area? Okay, so by calculating this one and then putting it back into here and then calculating all the values, this from where we can get this one. These are the statistics of a certain area. We can find it out. These are the statistics of a geographical area, that how percent are the males in a certain area and how percent are female, and this is also called a prior probability. And this is the marginal probability. We can marginalize this one because you can see that this and these things, this is also available here. Okay, this thing is also available here. So you can see that this is basically the percentile or ratio of one thing over the total thing. Okay, so by finding all the statistics, these are available, we can find out the probability that we have got a positive breast cancer case. What are the chances that the patient will be a male? We can find it out by here. Okay. Similarly, we can use it to find many scenarios. Basically, what is happening here is we have certain hypotheses. Let's say what will be the weather tomorrow? Okay, will it be a sunny weather or will it be a cloudy weather? So how can this is a hypothesis. We have certain thing in our mind that tomorrow will be a cloudy weather. So to find the probability of a cloudy weather, we have to find all these probabilities, and we will have a set, and from where we can get all these probabilities, these things will be available as a statistics of the previous years. Okay, all the previous year statistics can be put down here, and we can find the probability of a sunny weather or a cloudy weather and so on. So what will be this thing? This is called a posterior probability. This one is called a posterior probability. This is a posterior probability. Okay, what is this? I have told you guys in a class that this is called a likelihood. This is a likelihood. What is this? This is a prior probability. Okay, prior. What is basically a prior? That let's say there is a scenario. You have met a person, and from gestures and face expressions, it seems that that person is a very rough and tough person, and you cannot be friends with that person. Okay, he seems very rude and something like this. So what is the probability that what is the probability of his rudeness such that he met you? Okay, so this is the prior probability that he is a rude. So you will write the probability from the gestures and from all the expressions and your intuitive feeling that he is a rude by writing all these prior. Prior is, what is the prior? Prior is basically your initial belief, what is in your mind, what you think it will be, and so on. Similarly, in a weather case, that tomorrow will be a cloudy weather in this July, in this scorching weather. Tomorrow will be a cloudy weather. What is your prior belief? What is your instinctive feeling that tomorrow will be a cloudy weather? So this probability will be very low. But in very rainy season, what is the probability that tomorrow will be a cloudy weather? Your probability, or this prior probability, will be very higher. So this is your instinct feeling, and this is called a prior. It is just here. This is just a probability which will be in your mind. And what is this? This is called a marginal probability. Okay, just like we saw here, this is a joint probability. This one is a joint probability and a conditional probability, and again this is a marginal probability. We have discussed this thing. Similarly, this thing is again a marginal probability and an analytical form of this marginal probability. Okay, so let's move on. So this is again a Bayes theorem, and in this theorem, in this picture, we can see that we can find out the marginal probability very easily. Okay, this is the marginal probability. So how can we find it out? We can find out, as we have seen in our class, that when we discussed it, that what is the probability of A given B multiplied by the probability of B is this area, and so on. We have discussed it in the form of areas, and I hope it is clear, because we have discussed it in very detail in our class. Okay. So before moving on, I want to tell you guys that this is basically the last topic of our CLO1. After this thing, I will probably start chapter number 3, or after, I think, the binomial theorem, we will start chapter 3. And binomial theorem is also related to the CLO2 of our probability and random variables course. This was an important announcement. So let's move on. This is example 2.29, and what is it asking is, in a communication system, the receiver makes a random decision error with probability E. Basically, communication channels are the important applications of any probability and statistical theory. You have to apply all your probability, your random error rates, and all the things in communication channels, which you guys will study in your other semesters. So in this example, it is asking you to find different probabilities of error. Suppose that the receiver outputs a 1. Find the following. Okay, we have received 1 as the receiver. So what is this? What we have to find out? We have to find that what is the probability that the input was 0 and we have received 1. Okay, what was the probability that the input was 1 and we have received 1? So if the input was 0 and we have received 1, this is called an error. Okay, and all of this will depend upon the channel. We have a channel error rate, we have everything else. So if we have higher channel of higher noise, so the probability of getting 1 such that we have sent 0 will be higher as compared to the probability that we have sent 1 and we have get 1 as well. So here we have to find the same thing here in a generalized form. So let B0 the event that the input was 0 and B1 be the event that input was 1. Let A1 be the event that receiver output is 1. We have received 1. So the union of the event B0 and B1 gives the entire sample space. This is the entire sample space. For part A, we need to find out that what is the probability that the input was 0 such that we have received 1, and for part B, we have to find that what is the probability of 1 such that we have received 1 as well. So this is again a problem formulation. I have told you many times that how to approach a specific probability problem. Initially we have to write the sample space and then all the required probabilities, and if something I think everything will be written in comprehensive form. So you have to write all those things in the form of the mathematical equations and mathematical form, and after writing all those things you have to find the probabilities, and in these steps your probability of finding the required result will become very easy. So let's move on how to approach this problem. We have seen some events here and some inputs here. So okay, so assume that a priori the input is equally likely to be 0 or 1. Initially it is equally likely that we can send 0 or 1 because this is like a coin toss. We can either get a head or tail. So similarly, by sending 0 and 1, we have equal probability that we can that 0 or 1 can be sent. So using Bayes theorem, and we have this formula of Bayes theorem. Okay. This is a Bayes formula. Okay, so what is the probability that we have sent B1 such that we have sent 1 such that we have received 1 as well? This is equal to the probability that we have, what is the probability of getting 1 such that we have sent 1 as well, and what is the probability of 1, that is half. What is the probability of getting 1 as the output? How can we find out? Well, we can find out as I have told you guys that the probability of getting 1 such that we have sent 1 multiplied by the probability that we have sent 1 plus the probability of getting 1 such that we have sent 0 and multiplied by the probability of sending 0 as well. This is that thing. Okay, let me write it here. This is equal to the probability of getting 1 or A1 such that we have sent 1 as well, and the probability of 1 here. Okay, this thing, and plus this is, as this is the joint probability, so we have to consider all the cases. So here the probability of 1, so the unknown probability will always be this 1. Okay, getting 1 such that we have received 0, and the probability of 0 as well. Okay, we can find it out by this formula. So what is this? This is the received bit for A1. This is again A1. What is common between these two things is that here we have to find the probability of A1. Here we are also finding the probability of A1, but conditionally with another variable or another event which has previously been occurred. Okay, so assume that this is the formula. Using Bayes theorem, we know these formulas. Probability of one is the probability that the receiver detects 1 while the actual input was 0. It is the result I have told you guys, and we have told you guys that initially it was written that this probability will be this one, and the probability that we have received one side that 1 was sent is the probability that receiver will send 1, and this one, and this is again 1 minus e. Writing all these things here, we will get our final result. Similarly, writing all the other things here, we will get our final results as well. All these things are available. Okay, all these things are available. Let's move on. So and I have told you this is the formula which I have written earlier. Okay, I have written it in our previous slide. This is the same formula. Okay, and writing all the values here and all the other values, and taking all these values and putting it into our equation, we will get the desired result. So this was all about the Bayes theorem and an example of Bayes theorem. What we have discussed, what is a Bayes theorem, what are the issues in Bayes theorem, and what is it all about, that we have to find to get the probability of certain event or posterior probability such that likelihood is given, prior probability is given, and the marginal probability is also given. After it, we have to consider the independence of the event. What is the independence of event? Let me write here. Okay. Independence of event. We have discussed it in our class as well, but let me discuss it very briefly again. Independence of event. Okay, this is the topic. So if the probability of any event, let's say the probability of A such that B has already been occurred remains same as B has occurred or not, so it means the two events A and B are independent of each other. So let me give you an example. What is the probability that what is the probability that of azan, so that today is it is raining today? So is it possible that the probability of azan or taking a name of Allah subhanahu wa ta'ala at any instant of time will change with any event? No, it can't. Okay, we have to think that the times of prayers are independent of the weathers and weathers and situations, and times will remain same if it is raining or if it is sunny or something else. So the two events are then independent of each other. Similarly, if we are tossing a coin and we have let's say I am tossing a coin and I got heads in the first tail, what is the probability that I will get a heads in the second turn as well. Initially, when I was tossing a coin, initially I had a probability of 1 by 2 in the first file. So secondly, when this event has occurred, let's say this is B, probability of B. Okay, this is this one. This event B has occurred, and then I am tossing again a coin. So what is the chance? What is the probability of getting it heads again? So that I have got heads in the first file. So will it change? No, it won't. The probability of A is again half. Okay, so the probability of A is again half. So it can be seen that the independence, if two events A and B are independent, probability of, if two events A and B are independent, so their joint probability will be equal to the probability of A multiplied by the probability of B. Okay, this is basically the formula of the independence of events. We have discussed it in our class as well. How can we find it out? We can find it out by the base formula, by putting this value into our base formula or in the formula of our conditional probability. Okay, just write this thing in our conditional probability theorem, and we will see that we will get this one. Okay, and conditional probability theorem, when you will put this posterior probability and replace this posterior probability with this one, you will get this formula, and this is like this one. So this is the independence of event. That's all. This was all about CLO1 of our course. Next time we will start CLO2, in which we will talk about the binomial theorem, binomial probability law, and so on. What is your task? You have to do all the related examples, because in our next class we will also have a quiz related to CLO1. So please take all these things very seriously. So in today's class we have discussed Bayesian theorem. I will put some videos in the description which will tell that how Bayes theorem is important and where it is used nowadays. Please take a look over those videos and over this video as well. For finding the Bayes theorem, what are the important things? Basically, the most important thing is the likelihood of any event and prior probability of any event, and also the marginal probability of any event is also important. Bayes theorem is a modified form of a conditional probability. We have seen this thing. This is basically the modified form of the conditional probability. Similarly, after finding the probability of probability that a person is male if he tested positive with the breast cancer, we have found it out. Similarly, from the same problem, we can find the probability of many events, posterior probabilities of many events, and it can occur. It can be modeled in a similar fashion. Similarly, after this, we have discussed independence of events, how two events can be independent, what are the concepts behind independence of events, and what is meant by the independence and mutual exclusiveness. If two events are mutually exclusive, this is important point. I have forgot it earlier. So if two events are mutually exclusive or disjoint events, these two events are strongly dependent. Okay, just keep it in your mind. If something is not occurring, if something has occurred, it means the other thing hasn't occurred. Okay, the two things are mutually exclusive, and it means that these things cannot occur at the similar event. Okay, so that's the summary, and I hope you will study all these concepts, and if you got any question, any query, I will be available in your class as well. So till then, Allah Hafiz, and please practice all these things.